so we've been working with functions. Now we're going to be able to tell the difference between what a linear function is and what a nonlinear function looks like. When we talk about linear, we're talking about what is a straight line, and that does not mean that it's more than one straight line. It's just one slope. For nonlinear functions, it would just not. It's not a straight line. We're just reviewing. Okay, so over here on this column, this was what was linear, and then on this side, it's what is not linear, okay, or non-linear. So anything on this side is a linear function, and in fact, we're just going to take the same function and show it in different representations. So the first one, this is an equation. Notice that it does not have any exponents, so no exponents is the big thing you need to look for. Okay, and the other thing is no variables in a denominator. Okay, if it doesn't have exponents and it doesn't have any variables in a denominator, then it's likely a linear function. There are other things that also make something a linear function. You have to check for absolute value and also a variable times a variable. The reason that we check for those things is because a variable times a variable would actually be an exponent, like x times x is x squared. In absolute value, it only covers those positive values, so or distance from 0. So that would make our graph have double stacked points. All right, then in this table, we just take -2, 0, 2, and 4 and input it in for x. So 2 times -2 plus 3 is 0 times 2 plus 3 is 2 times 2 plus 3, and 2 times 4 plus 3, 11. Okay, and then from here, we just listed these as ordered pairs. So this first ordered pair is -2, -1, because x always comes before y. Then 0, 3, then 2, 7, and then 4, 11. Okay, and from here, we're going to graph them on this graph below and talk about what it looks like on a graph. Now, if this is a linear function, then what type of graph are we going to be looking at? What type of line? It's going to be a straight line, right? Okay, so I want you to adjust this so that the x-axis and the y-axis are here if you haven't done that. So this starts at -2, -1, 0, 1, 2, 3, 4, and this is positive 1, 2, 3, 4, 5, 6. All right, we'll just graph what will show up on the graph easily. So -2, -1, that's just what estimated to be here. 0, 3, and then we have 2, and there's 6, go up 1, 7. Okay, and then we would show that these are a linear function by drawing that straight line through them. So this is a linear function. Its slope is constant. Okay, remember slope is rise over run. On this one, how far up does this travel before we have to move to the right? It's up 1, 2, 3, 4, and over 2. And the same thing happens here, up 4, over 2. So that's how we know that the slope is the same each and every single time. All right, at the very bottom, the starred part, equations are linear. The two big things that you need to take away from this, equations are linear if they do not have, what are the two things I said? Exponents or variable in a denominator. And what is the denominator? The bottom of a fraction, right? All right, so now back at the top where everything is a nonlinear function. Why is this one nonlinear? It has an exponent. Okay, the exponent is what makes it nonlinear. So when we fill this chart out, we're going to expect something to change its direction. So whenever you take this, make sure you take the x value squared, or x value times itself, plus 2. So -2 squared plus 2 is, 0 squared plus 2 is, and 2 squared plus 2 is, and 4 squared plus 8 plus 2 is. Thank you. Okay, And notice that we end up with two of the same output, so that's going to give us a hint that it's not going to be a straight line, because they wouldn't be able to share those outputs. That doesn't have anything to do with it being a function. It's still a function. It's just not a linear function. Okay, so don't get that messed up. So now we would copy down those points and graph them on the graph. So we have negative 2, 6, 0, 2, 2, 6, and 4, 18. Okay, so whenever we put this on the graph, we're going to see that those points are actually not showing the same slope all the way across it. It's still the same setup. So this first order pair is going to be here at the top, negative 2, 6, 0, 2, and 2, 6. And you see that this, in fact, is not a straight line. It's two straight lines connecting, but it's definitely not a straight line. Okay, one more thing to recap. I graphed 3 lines on one graph together. Okay. We're talking about whether it's linear or non-linear, not about whether it is a function or not. So this one is linear because it is a straight line, but look at the red one. A lot of people want to say that this one is linear because it's technically 2 straight lines, but we're talking about it has to be one continuous straight line. So this red one is non-linear. So just kind of keep that in mind.